Hi, this is Professor Muldrow, and I'm redoing the recording for the MIPS that I tried to do in class the other day. Let's go through the PowerPoints. Here we have all the registers that can be used in MIPS. Feel free to look at the PowerPoint slides to refresh your memory. The ones we will use right now are the T registers, because they are temporary values, and the S registers, because they hold values for variables. Now, if you have C code like this, x equals 8, y equals 5, you're just putting a constant number into a variable. Anything involving a constant number in MIPS is called an immediate. And if you're going to do something like this in C, you need to use the load immediate instruction in MIPS, LI. So here, x is equal to 8. If x gets the register S0, the equivalent instruction in MIPS is LI $S08. Similarly, y equals 5 and y gets S1 register. That becomes LI $S15 in MIPS. Now, we did not use LI in the labs. They were not needed in the labs, but they will be needed in the homework assignment, which I'll do a separate video on for using the MARS tool. If you're going to add a constant number like this, x equals x plus 20, well, then you have to do add I. Now, your destination comes first. That's x. We're assuming x gets S0. So S0 is your destination. It also happens to be a source since it's x plus x20, and then you put the constant number on the end, and there is the add I instruction. Add I S0, destination, S0 also happens to be the source, and 20. There is no subtract immediate. You can't use a sub I in MIPS. So what you have to do if you're subtracting like this, x equals x minus 1, is it's still add I S0, destination, x, S0, source, also happens to be x, and then if you're subtracting 1, you put a negative number at the end. In this case, it's a minus 1. So that's how you subtract a constant number in MIPS. Now if you're adding and only involving variables, no constant numbers, now it's all registers involved, so you don't use add I, you use add. And here we got A, B, C. A equals B plus C, I'm sorry. So once again, S0, that's what A's register is, that's your destination. S1, first source, is B, and S2, second source, that's C. So S0, A gets B plus C. When you're subtracting with all registers and no constant numbers, there is a sub for subtract instruction for that. And it works the same way the add does. Your destination is A, first source, B, S1, second source, C, S2. This should be B minus C right here, but the order of these operands is important. In subtraction, B is the first source, so it must be the second register here, and C must come after that. Order matters for subtraction. Here we have multiple instructions, and now we got parentheses involved. We have to handle the parentheses first. That's just the order of math operations. So that means we need to do the z plus w first, but since that's not the last math operation we do, we don't want to put z plus w into x. We want to wait until after y subtracts that and then put it into x. That's why when you do add for z plus w, here z gets S2 and w gets S3, they're your sources, but you're going to put the result of that into a temporary register, in this case T0, because it's going to be used in another instruction coming up. Now that you've got this addition out of the way, now you need to finish the subtraction. So here's the sub instruction. X is your source, that's S0. X is your destination, that's S0. Y is your first source, that's S1. And now you want to put the result of z plus w into another register, but that's in T0. So that's why T0 comes last here. T0 already has the result of z plus w. So it's sub S0 for x, S1 for y, and then T0, which has the result of z plus w. And now we got two parentheses, which works the same way. So you got to handle each parenthesis left to right. So first we do g plus h. So add, that'll go in a temporary since it's not the end of the math over here. And so T0 is the destination, S1 for G and S2 for H are your sources. Now you handle this second parenthesis. So add again, it'll go into a second temporary, T1. S3 is a source for I, S4 is a source for J. And then finally, now that you got all those parentheses taken care of, now it's time to subtract. Here's the sub instruction. S0 is your destination, that's what F gets. And you're subtracting T0, which has G plus H, and then minus T1, which is I plus J. That's how that works. Now, when it came to arrays, we're assuming in MIPS, for our purposes, that arrays will be integer arrays. That means each element of the array contains 32 bits worth of data, which is the same thing as saying 4 bytes worth of data. So that means in an array, we always have consecutive memory addresses for the elements. But in this case, since each element requires 4 bytes of storage, that means these addresses, you must add 4 to each one to go to the next. The first element here is at address 1000. The second one is at address 1004. You don't add 1 to go to the next one, you add 4 because these are 32-bit integers. Now in MIPS, if an array has in C, if an array has 5 elements, you'd access those elements this way, like the array is named A bracket 0, bracket 1, bracket, all the way to A bracket 4. In MIPS, if you're going to do this in the Mars tool, the first thing you need to do is this load address instruction. We'll assume that this capital A represents the starting address of the array. You're going to put that into S3. So that's where this will go, LA-S3. Now again, LA was not used in the labs. It will, however, need to be used on the homework. So the equivalent of these 5 statements in C, A bracket 0, would be this. Now S3 has the starting address of the array. You need to put an offset outside of that. First put S3 in parentheses, and then some offset value that you add to this address. Well, since it's A bracket 0, well, you just put a 0 out there. But if it's A bracket 1, your offset has to be a 4 because MIPS is accessing the memory directly, and to get to this A bracket 1, which is the second element of the array, you got to add 4 to get to the second element's address. An easier way to remember this is, okay, if in C it's A bracket 1, you take whatever the index is and multiply it by 4, and that's the offset in MIPS. So A bracket 1, 1 times 4 is 4. A bracket 2, 2 times 4 is 8. The instructions we'll use are load word, LW, and store word, SW. Load word is when you're taking something from an array and you're going to put it into a different register or variable. Store word is when you're putting something that's in a register into the array. You're changing an array element's value. However, store word is an exception to the rule around here. Almost every other instruction has the destination first and the source or sources second. Store word is the opposite. It puts the source first and the destination second, as you will soon see. All right, so here we have an example, x equals A bracket 2. The base address of the array is in S1. So the array is on the right side of the equal sign. Whenever you have an array on the right side of the equal sign, that means you're going to use a load word to get that value. And it's going right into a variable. So there's no need for a temporary on this one. We just say load word, S0, that's x's register, so that's your destination. And then to get A bracket 2, S1 is where the array begins, so you put that in parentheses, and the index in C is 2, so you multiply 2 by 4, and that gives you 8, and that's why an 8 is in front here. So there is your load word instruction. That is the same as this C instruction. Now we're using an array again, but this time we're not just saying G equals A bracket 8, we're saying G equals H plus A bracket 8. You still want to take care of the array first on the right side. Anytime you have an array over here, take care of it first, no matter where it is. The thing is, though, we're not just putting A bracket 8 directly into G. We have some math over here, so that means this A bracket 8 needs to go into a temporary. So once again, it's on the right side, so there's a load word. We're going to put it into T0 since we're going to add it later. And then to get the proper element, we put S3, since that's the base address of the array, in parentheses. The index in C is 8. Multiply that by 4. That gives you 32. And so that means your load word you go is T0 and then 32 parentheses S3. So T0 gets the element that's at A bracket 8. But once that's done, now you got to add it to H, then put the result in G. So here is the add instruction. G is your destination. That's S1. That's G's register. H is your first source, that's S2, that's H's register, and then you want to add A bracket 8. Well, A bracket 8, its value is contained in T0, so that's why T0 is your second source for this example. And now we have an array on the left and the right side of an expression. Once again, you got an array on the right side, that's going to involve a load word. It's going to have to go into a temporary because we are adding. However, we now have an array on the left side of the equal sign. That means you're going to put a value into A bracket 12. You're putting something into the array to take care of A bracket 12. Since that's on the left side, that requires a store word. So let's see what happens. First, you have to take care of A bracket 8. Take care of the array on the right side first, always. So that's a load word. We're going to add, so it goes into T0. And again, 8 multiplied by 32, that's 32 parentheses S3, since the base address of the array is in S3. Now you're going to add, but since you're going to put this into an array, you're not going to you're going to use another temporary register. In this case, we're going to put it right back in T0. So here we have, let's see, T0 is going to be our destination again. H is the first source, that's S2, and A bracket 8 is your second source, that's currently stored in T0. So I'm going to add what's in S2, that's H, and what's in T0, that's A bracket 8. And when I get that value, I'm just going to put that value back into T0. You could have used another temporary like T1 if you wanted to, but in this case it's not really needed. And then finally, now T0 has the result of H plus A bracket 8. So now we need to put that into A bracket 12. Here is the store word. You're putting it into the array. Like I said with store word, your source comes first, not your destination. So T0, which has the value that goes into the array, that comes first. And then the destination, where it's going in the array, comes last. Again, S3 is the base address of the array. And for A12, you take 12 and multiply it by 4. That gives you a 48. And that is your store word instruction. And that's how it works in MIPS. Like I said, I will have a separate video for the MARS tool for the homework later on. If you have any questions, send me an email, kmuldrow@lbcc.edu.